Right, hello everyone. So in this video, we're going to go through two proofs. So one involving angles and then the other involving midpoint. So starting off with this one, we're told to write a two-column proof, and we're given this diagram over here with angles 1, 2, and 3. Okay, so I always start with my givens. So if I state my givens, we have the measure of 1 equals the measure of angle 3, and that is given. Okay, so if I look at what else I can prove here, so what I'm trying to prove ultimately is that EBA, so EBA is this angle here, is equal to the measure of DBC. So we want to prove that this red and this green one are equal. Okay, so what I can do is if I'm ultimately trying to get to this EBA, this red one here, just like with the Uno cards, that's my ultimate angle. I want to include EBA. So if I ask myself, what do I know about EBA? Well, it's made up of angles 2 and 3, right? So if I add 2 and 3 together, so let's write that out. So the measure of angle 2 plus the measure of angle 3, we get the entire angle, which is the measure of EBA. Okay, so like I said, we want to be strategic with these, like the Uno cards. If I ultimately want to get to this red, let's integrate this into the proof so we could ultimately get there. Okay, so I ask myself, what's my reason for this? How do I know that these two pieces add up to the whole? Well, that's the angle addition postulate, right? So angle addition postulate. Okay, so if I look at what I have now, well, I have angle 3 twice, right? So if I have angle 3 here, but I know angle 3 is equal to angle 1, so I can substitute, right? So I can either write angle 1 or angle 3. So if I substitute in 1 here, I would get, so the measure of angle 2 plus, so instead of the angle 3 here, I'm going to substitute in 1 because I know that they're the same. Okay, so that'll be my substitution property, right? So substitution of equality. Okay, so looking back, if I look at angles 1 and 2, so if I go back to my diagram, well, 1 and 2 together is the green angle, which is DBC, which we also need to integrate to our proof. So I can also state that, right? So DBC is made up of 1 and 2, right? So if I add up 1 and 2, so the measure of, I'll keep the same order, but either way, 1 and 2, 2 and 1. So that gives me angle DBC. It's DBC. Right, so once again, we're adding the two smaller pieces to get the entire green one here, right? So if that's the angle addition postulate, right? So we're using that one twice, so angle addition postulate. Okay, it looks like we're almost done because now I have the two angles that I need, EBA and DBC. Well, they're equal to the same thing, right? So EBA is equal to 2 plus 1, and DBC is equal to 2 plus 1. Right, so what property can I use to state that these two are equal? Right, so that should be, let me write it out first. So EBA equals DBC. That's our transitive property, right? If two things are equal to the same thing, I can set them equal to each other. So that's my transitive property of equality. I'll add of equality here as well, just to have the full names. And that's what we're trying to prove, right? So this proof works nicely. It's very similar to the Uno card. You look at where you're trying to end up, and then you can write what you know. And then using some properties, we can get there. So a little bit of substitution and angle addition postulates. All right, let's look at one more. So this is actually going to be one of our theorems that we're going to use, and we're going to have to be specific about this one. So the midpoint theorem. Okay, so we want to prove that AM is half of AB. So basically this piece is half of the whole, which if M is the midpoint, which we're given, we know that's true, right? Because it's the midpoint splits it into two equal pieces. So if my entire thing is 10, each piece would be 5, right? So that's our midpoint theorem, that each piece is half of the entire one. Okay, so let's write our proof. So we need a statements column. I'm just going to put an S and a reasons column. So statements and reasons. Okay, so let's start out with our given. So we're given that M is the midpoint of AB. All right, so let's see what we can state first. So starting off, first thing I think I will be able to state here is that if I know M is the midpoint, well then this piece has to be equal to this piece, right? So I could state that AM is equal to MB. Or you could put the segment symbol on top and write congruent if you're talking about the actual shape. But we'll take the length of AM is equal to the length of MB. And my reason for that would be definition of midpoint, right? So definition of midpoint. Okay, so what else do I know? Well, similar to the last one, if I add up the two pieces, I get the whole. So I think that might help me down the line. So let's use our addition postulate. So I could say that AM plus MB is equal to AB. And that's our segment addition postulate, right? So if I add the two pieces, I get the whole. All right. Okay, so ultimately, if I look at what I'm trying to prove, so let's look at that final Uno card we're trying to get through. We ultimately want to get here. So we have AB in an equation, so that's good. We have AM, but I only want AM. I need to get rid of MB. So what I can do, well, if I know AM and MB are the same, I can just substitute to get only AM, because we want only AM over here. So if I put in AM, use my substitution property, I can get AM plus AM is equal to AB. So I can substitute there, so substitution property. And if I look at this, just like x plus x is 2x, like 1x plus 1x, so this is 1am plus 1am, so this would be equal to 2am equals AB. Right, so I can just, if you want to put a reason, you can just say simplify, but I could just add those together. All right, so finally, if I look at so I want am by itself, so to get the I need a half over here, right? So I need half AB. So if I want to get half, I can just divide by 2, right? So if I divide both sides by 2, I'll get AM by itself, and then 2. So I could divide by 2 or just take a half of each side, right? So if I take a half of each side, half of 2 is just 1. So 1 AM is equal to half AB. So I can, two different ways I could do this. So we multiply by half, so that's the multiplication property, or if you divide by 2, you can also say division property. Since I use the half, I'll say multiplication, but either one would be acceptable based on which one you did. So that's the multiplication property of equality. Okay, and that's what we're trying to prove. And it also says to prove this one, so MB is equal to half AB. So we already have the half AB here, so if I want an MB over here, well, I know AM and MB are equal to each other, right? So instead of writing AM, I could just substitute MB in here and have MB is equal to half AB. And we'll write that. So that's our substitution property. Because if I have two things equal, I can just substitute and replace one with it. Okay, and this is what we're trying to prove. So that is what my proof will look like. So we were very strategic here with the substitution, but ultimately we got to where we need to be. Okay, so one important thing to note to finish this off is this is the midpoint theorem, that each piece is half. So for example, if I'm given that B is the mid, so if I have segment AC here, and I'm given that B is the midpoint. Remember, definition of midpoint means that this piece, so AB, is equal or congruent to BC, so that the pieces are equal or congruent. That's definition of midpoint. However, if I wanted to say that one of the pieces was half the total, so half of AC, so if I take half of the total, I get one of the pieces, so something like this. So if you take half of the total, you get this piece. This is the midpoint theorem. Okay, so in proofs, we have to differentiate between definition of midpoint and midpoint theorem. So when you're talking about the length and being half, that's the midpoint theorem. When you're talking about the two pieces be equal, that's definition of midpoint. So just to clarify that. All right, I hope this video was helpful. Thank you for watching.